Hello, I've been working a little bit on the background subtraction on our XAS data. And Jocelyn, you'll recall that you sent me data that looks like this. And so it looks like you had interpolated it properly, but we have some issues with getting the background subtraction going. So I just did a background subtraction, and the ending data looks like this. You'll notice that from 260 to 280, it looks pretty good. I have not done the atomic normalization, and I just want to show you quickly what I did, and you can kind of take it as a possible route that we can do to get this thing up on its feet. Now what I did is I only did the work on a very small subset of data. And what I did is I took your interpolated set, I downloaded it into a new file folder. So I just called it N10 LinearBG. But then I knew that this couldn't necessarily work properly, so I made a new one called N11, which also had the reduced data set in there. So the same things that you see right here after the background are in N10, but then I'm about to do N11. And you'll notice that as I display the data set, it's not background subtracted. So let me go ahead and say display. And we'll get that data up. Pantograph, pantograph. I tried to do the batch way, but then it says the data set is too big, and I'm not sure why that is. That seems pretty silly to me. But anyway, we're going manual so we can get to what we need to do. Okay, so you notice all of this is all over the place. I'm going to give it some color just so you can differentiate between everything. And here we are, we're looking at our data. Hopefully we should end up something similar to what we have right there after we're done. So this is what I'm doing. I'm going back over into our batch folder, and I am going to select on LinearBG 2, which was our duplicate that I created just so I could do some of the work. I'm going to go back to batch function, and I'm going to go to our classic sublin.bg on set. And what I'm going to do is I'm going to go from 260 to 280, which should be that pre-edge area in which we've got no work readily being done, and we shouldn't have any photo emission. And then I'm going to hit continue. Now look over here to the right hand side and see how these guys change in real time as we do the work. And it gave us some little function execution error, ynav was null or missing. But you'll notice once we've done that, and these are that high-res set of scans, and you can see that those are all in the 300, similar to what you had plotted previously, that we've got all of the background properly subtracted, and it looks pretty good. And the next thing would be to do the atomic normalization. Now from my notes, the atomic normalization that I have, you'd assume would be at that high energy level. You know, it has to be from the edge back to 390 or something along those lines. So this should move us in the right direction. We should both be seeing this prior to atomic normalization. So I'm going to go ahead and stop doing this, and I'm going to send it your way, and you let me know what you see. But I think we're closer to what we should be achieving here. Okay, bye-bye.